Hello everyone, welcome back to the lecture series of KT in Data Science and Artificial Intelligence. This is the lecture for database management and warehousing system. So in the last lecture, we have discussed about the relational algebra, like basic operators like projection, selection, rename, and then in the last video, we have discussed about set operation like union, intersect, and except, right? Now in this video, we are going to discuss about the joins in SQL or joins in relational algebra, okay? Not in SQL, joins in relational algebra. So we are going to discuss an overview of joins used in the relational algebra because we are going to discuss in detail when we are covering the SQL part, okay? So this is the part 3 for relational algebra. So part 1 and part 2 we already covered. You can watch it on the YouTube, okay? So let's start the session. Now in this session, we are going to cover the join. Okay. So up till now in part 1, part 2, or even in the tutorial, we have dealt with the only one table, that is student table, right? But you know that in the case of relational database, we have multiple table linked to each other, right? Then in that case, suppose if you want to get the information from more than two tables, right? More than one table or two tables, then in that case, how to get that particular information or data, right? Either we need to join that particular data or we need some reference so that we can collect data from one table to another. If you observe here for a student named Ravi, okay, his roll number is DS01, age is 23 and course DBMS, right? But I want the information of a Ravi, that Ravi belongs to which department, right? Now, in order to get the department of a Ravi, I need to go to the enrollment table, right? Now here you can see department is mechanical, but how I can link this two table with each other, right? So here you can see there must be some common attribute, right? There must be some common attribute. So roll number in this case is a common attribute, right? Otherwise, we cannot map the two tables, right? For mapping purpose, we need something in common, right? So that is a common attribute. If I want the department of Ravi, then what I can do? Okay, this is the Ravi, this is the student table. So student name is equals to Ravi. So I can get the roll number of a Ravi from here, this table. And by using this particular roll number, I can go to this particular enrollment table and see, okay, for this particular roll number, the department is mechanical. So it means the department of a Ravi is mechanical, right? So that's how we can get information by joining or by using the two tables, right? But in the right? But in the case of SQL or relation algebra, like we need to join these two tables, right? And for joining purpose, there must be some common attribute, right? There must be some common attribute. So you can say roll number, roll number. Now there are different types of joins. The first one is Cartesian product. So basically a matrix multiplication here, or cross join also, right? That is cross join. Cross join. Okay. So here I am referring student as S and here enrollment as E. Okay. So first is Cartesian product, that is cross join, that is student cross E, right? Now what is Cartesian product or cross join do in the case of multiplication or in the case of matrix? It will give us the combination of each and every row with other tables from each and every row, right? For example, DA001 Ravi 23 DBMS will map to this particular row. Same row will map to this all the rows in a enrollment table, right? So here you will get the four rows belong to this particular uh, roll number. Now in this case, like for Java also again there will be four rows, right? So in this case, if we follow the in the output of S cross E, right, it's S Cartesian product E, how many rows will be there? So in total there are 1, 2, 3, 4, 5, 6. So total there are 6 rows here and here it is 4 rows, right? So in total there will be 24 rows, okay? In total there will be 24 rows in the output of S cross E table, okay? So those are not understanding this cross join, don't worry, we're going to discuss in SQL part in detail. In that you can see like how in that you can visualize this particular join, okay? So as of now, just remember for relational algebra, this cross represent the Cartesian product, okay? Cartesian product. If even if the two table don't have any common attribute, okay? Say for example, instead of roll number, it is just say student ID, okay? Student ID, right? Like this, right? So student ID and roll number, these two are a different attribute because the names are different, right? Even though the rows are same, but the names are different, right? So in this case, cross join will be performed, right? S cross E, right? So there are no common attributes, right? In the case of cross join, we don't require any common attribute. It will simply give us the combination of each and every row with all the rows in a particular table. The combination of this row with all the rows, the combination of this row with all the rows. So this is what the Cartesian product is, right? So combination of all the rows of one table, it will give us with the another table, right? So this is basically a Cartesian product. In this case, we will have 6 into 4, that is 24 rows. And how many columns will be there? 1, 2, 3, 4, 5, 6, 7. This 7 columns, right? That is 7 columns, right? In the case of Cartesian product, the number of rows of two tables, suppose T1 cross T2 is there, right? So the number of rows will be R1 into R2. If R1 is the number of rows in T1, R2 is the number of rows in T2, right? And number of columns will be in the Cartesian product, it will be C1 plus C2. So C1 and C2 are the number of columns in T1 and T2, right? So please remember this. We'll discuss in detail in SQL part, but still remember this. A question can be asked from this particular question, right? So this is regarding the Cartesian product. Now, how to write a relation algebra query for this, right? For example, I just want the name and department of the student, right? So what I will do, pi name comma department, right? Then in bracket I can simply put student cross join enrollment, right? Enrollment. Now in this case, what we'll get, first it will perform the cross join, right? Student cross enrollment. So we'll get 24 rows, right? Like combination of each row with each row from this particular enrollment table. And from the output of this particular cross join, we will fetch name and department column, right? So name and department column. Now in this case, but we'll not get a meaningful data, right? We'll simply get the combination of name and department. That's it. Ravi Mechanical, Ravi Civil, Ravi Computer Science, Ravi Mechanical again. So it will not get repeated, but Ravi Mechanical, Civil, Computer Science will get repeated. Raj Mechanical, Raj Civil, Raj Computer Science will get repeated. Shubham Mechanical, Shubham Civil, Shubham Computer Science will be there. So, right. So in this way, we'll get a different output, right? So in this way, we'll get the output, right? But name and department, but we'll not get like Ravi is belong to which department, right? For that, we need to join these two tables based on this particular roll number. Then only we can get the information about the student and this department, right? And how to mention that? So same thing, I can write this as name, department. Okay. Now in the bracket, I can write use the sigma function, which is condition function. So condition student. Okay. So student dot roll number, right? So student dot roll number is from student table. We are taking the roll number. Now in this case, there are two tables, right? So we have to specify from which table we are using the column. So student dot roll number must be equals to enrollment dot roll number, right? This is a selection condition, and in the bracket we can mention student across enrollment, right? Now in this case, what will be the output? In this case, we will get Ravi Mechanical only, right? Because it will match the roll number ID also, right? Previously, we are getting the combination of Ravi Mechanical, Ravi Civil, Ravi Computer Science in this case, right? Now what will happen? First, it will perform the cross join, and then it will apply this particular condition. So roll number must be equal from both the tables, right? Now in this case, I will get Ravi Mechanical. Raj belongs to roll number DA02, but here DA02 is not present, so Raj will not be included. What about Shivam? Shivam DA03. Now DA03 is present, but belongs to civil department, right? So the Shivam belongs to a civil department, right? So output will be like this: name and department will be there, and name and department will be there, and output will be same thing, right? Like Ravi Mechanical, then Shubham civil, then 4 D04 is not present, D05 is present. Then Rajesh belongs to which department? Computer science, right? And then last one is which one? DH06, that is Ramesh belongs to mechanical again, right? So 4 rows we'll get, right, based on the particular condition. So we'll discuss with one example in the next tutorial, so don't worry about it. But as of now, just understood, this is the Cartesian product symbol. In the Cartesian product, what happens? We'll get the combination of each row with with each and every row of the other table, right? So this is basically a Cartesian product. And if we want some meaningful data, so what we can do based on some common attributes, here you can say student dot roll number equals to enrollment dot roll number, because we have to specify this. Based on this, it will join the two table, right? Then only we'll get the meaningful data, right? So this is how cross join works, right? Okay. Now, one more thing, if you observe in the last example, we have taken name and department, right? Name and department, that we applied the condition that student dot roll number equals to enrollment dot roll number, because we are using two table here. So our SQL query should know which from which table we have to select the column, right? So apply the condition to the particular column, right? So that's why we are mentioning that like this. So student dot enrollment, right? This is the query, that's what we have discussed now. One more thing, okay? So name of a student and department whose age is greater than 21. Now whose age is greater than 21. Now I want to put one more condition here. Now in this case, what will happen? Same thing will be there, right? By name, department, then in the bracket, what I will do? In bracket, what I will do? Sigma operator, student dot roll number equals to enrollment dot roll number. Now we have to use AND because there are more than one condition, right? So I will use AND operator. And so please remember this, all the conditions are going in the subscript of this particular sigma, okay? So sigma, and then we have to specify that student dot age is greater than 21, right? And then we can mention student cross join enrollment, okay? So we'll discuss like what will the output of this particular query, but as of now just understood we can mention like this because we can use this AND OR operator if we want to use multiple condition inside the selection function, right? So this is how we can write the SQL query to get the data of a name and department of a student whose age is greater than 21, right? Using both the tables. But if you observe here, every time I need to write student, enrollment, students, and because whenever I am applying any particular condition, like in this case, I have to specify from which column, right? So that is important thing. So what we can do? So if we have some say 2-3 conditions in that, and we have to project 2-3 attributes, then in that case it will become very complicated to write the query, right? Now here we can use the rename operator. So how rename operator? So suppose name comma department. Now here also you can use student dot name and enrollment dot department like this, okay? Here also you have to use, because it is better to specify from which table we are using name and department column, right? Now what I am saying, sigma s dot roll number, okay? Now I am not using the student name, s dot roll number, e dot roll number, and s dot age greater than 21. Now, what is S, what is E here? We have to specify that, right? Because we don't know what is S, what is E. Then in that case, we can use the rename operator here. So row operator. Now this is S, and in the bracket I can mention student, right? Student, and then the cross join. Again the row operator, that is enrollment E. In the bracket I can mention the enrollment, right? Enrollment, right? So this will be the correct way to write the relational algebra expression, because we have to specify that S belongs to student, E belongs to enrollment. So we have renamed the student name as S, we have renamed the enrollment as E. So we can simply mention S dot age greater than 21, S dot roll number equals to E dot roll number, right? Or here also you can mention S dot name or E dot department like this. Okay. But I hope you understand what is Cartesian product is and how to write the SQL and how to frame the relational algebra and why we are using this rename operator here like this. Okay. Okay. Now about the natural join. Okay. So we have discussed about the cross join. Now about the natural join. Okay. So symbol of natural join is like this. Okay. So symbol of natural join. Now what natural join will do? Join the tables based on common attribute. Okay. based on the common attributes. If there are one common attributes, then based on one common attribute, it will join. If there are more than one common attributes, then it will take the combination of those two attributes to join the table, right? Now, in this case, you can see roll number and roll number is a common attribute, right? Now, in order to perform natural join, there must be some common attribute. Now, in the previous case, even if this roll number is not mentioned, instead of roll number, some student ID is mentioned, right? We are not worrying about it because cross product will not be joined based on the roll number. It will simply give us the combination of each and every row with every other row in the table, right? So in this case, we can simply just rename it like enrollment.student ID, enrollment.student ID, and here also you can write e.student ID, right? In the case of Cartesian product, it will not matter. But in the case of natural join, because natural join will join the table based on the common attributes only, there must be some common attribute in order to join the two tables, right? Now, how to represent this? Now, same thing we'll do. Now, pi, name, and department. So, I want a name and department from this particular tables, right? Now, how to use this student query? Now, how to use this particular natural join? Simply, I can mention student and this particular symbol, this natural join, enrollment, right? Enrollment. Now I will get a name and department of a student based on the roll number, because it will join the tables based on the roll number. So I will get Ravi, mechanical, Raj is not present, Shubham, civil, then I will get Rajesh, computer science, and I will get Ramesh, mechanical, right? So this will be the output, right? So the output of this particular query is equivalent to this query. Okay, so the output of the query in the natural join is equivalent to this particular query. Okay, but here we have to specify this particular condition, right? But in the case of natural join, we don't have to specify because it will join based on the common attributes only, right? So output in both the case will be same because we are joining based on the common attribute, right? Now, what if instead of roll number there is student ID, right? Then if we perform the natural join, then in that case there will be no common attribute between the two tables. And if we perform the natural join, then in this case it will act as a cross join. Okay, then it will act as a cross join. So please remember, in case of natural join, if there are no common attributes, it will perform Cartesian product or Cartesian join, you can say, right? If there are no common attributes, right? So this is the important point you have to keep in mind, because question can be asked based on this. Very important point to note. Now, in the case of cross join, if you observe, we got R1 into R2 rows, right? And C1 plus C2 rows. But in this case, it will not happen like this. In the case of natural join, based on this particular common attribute, it will join. So in this case, the number of column will be 1, 2, 3, 4, only 4, right? And the number of columns will be 2, right? Now, if I just perform the natural join operation, that is student natural join enrollment, okay, I am not projecting anything, not applying any condition. So in this case, I will get 4 rows. In this case, I will get 4 rows because for each roll number, there is only one entry in the enrollment table. So it will map based on the roll number. So I will get the 4 rows, but number of columns will be roll number, name, age, course, department, and admission year. So that is 6 columns, right? That will be 6 columns. Please remember that in the case of Cartesian product, there will be the 7 table, that is C1 plus C2, that is 4 plus 3, that is 7. But in the case of natural join, it will be a 6 column because these columns are same, right? So common columns will not be repeated in the output. In the case of Cartesian product, common column will be repeated, but in the case of natural join, common column will not be get repeated, right? So we'll discuss practically by using SQL how this works, but as of now, just understood that this is the natural join symbol, and based on the common attribute we are joining the tables. Okay. Okay. Now next is the theta join. Okay, that is theta join. Same symbol, same natural join symbol, but only the theta is mentioned here. Now what is theta? Theta is basically the joining condition. Joining condition, or any condition, we can say any condition. Okay. So for example, just take project name and department, right, and say student natural join. In the theta I will mention age greater than 21, then enrollment. Okay, so we are applying the joining condition here inside the instead of theta, right? So here theta equals to our age greater than 21, right? Now if you observe, this is equivalent to this query: phi name department, then sigma operator we have to use for condition age greater than 21, and then student natural join symbol only, and it is enrollment. Okay, enrollment, right? So these two are equivalent. Only thing is that here we are specifying the condition, and here the condition is applied based on the theta join. Okay, but the output will be same in both the case, but the execution of both the query will be different, right? The output will be same. Okay, output will be same, but execution is different. But execution will be different. Okay, will be different. We'll discuss this in detail, don't worry. The output will be same, but execution will be different. But these two are the equivalent relational algebra expression, we can say, because it will give the same output, right? So only thing is that this is the natural join and this is theta join. Okay, and this is theta join, and this theta join is equivalent to sigma theta then natural join. Okay, so basically we are applying the this theta condition inside the sigma operator, right? That's it. So this is about the theta join. Okay, so I hope you understand the Cartesian product, then the natural join and theta join. Only these three types of join will be using in the relational algebra. So that's it. So nothing in that. So this is the Cartesian, this is natural, and this is theta join. Okay, so I hope you understand this particular concept. Like in the next tutorial we are going to discuss the some problems. Okay, so we'll discuss few questions also, so don't worry about it. And in that if you observe here, for solving all the expression, we only required the relation name and this particular attribute, right? We do not require the data present in the table. So this is the relation name and this is the particular attributes, right? So in the next tutorial, from the next video onwards, what I will do, student is my table. In the bracket I will mention a roll number, that is name, and this is age, and this is course. Okay, so this is the schema of this particular table. So this is the schema of this particular table. And what is the schema of this particular table? Enrollment. So enrollment, in the bracket I can mention column name, that is department, admission year, and roll number. That's it. Because this is enough to perform any relational algebra expression or write a SQL query. Because for writing SQL query, we do not look at the data, because here only like 10 or 15 rows are there. But in the case of real world database, there will be more than 40-50,000 rows, right? So we never look at the data for writing the SQL query. We are simply looking at the table name and then column name. Okay, and here one more thing is that here roll number is a key means it must be unique and not null. So we can underline it by we can underline that particular attribute. So here also you can say roll number is a key, but we have not specified that. But here we have to specify, right? So we have specified that roll number is a primary key, so it should be unique and not null. So in the next tutorial I will be using this type of notation, like student table, and inside the bracket there will be columns. Here also enrollment table, and inside the bracket there will be some columns, right? In the GATE exam you can expect the relation like this only: student, then in the bracket tables, in the bracket columns, right? So I don't think they will give the data because data is not required. They will only give the schema of a table and you need to write a relational algebra expression. So okay, that's it from this particular lecture. See you in the next tutorial. Thank you.